Hello everyone and welcome to our 3.4 notes on proving lines perpendicular. So we're going to get started with a few different theorems. The first thing we're going to look at is something called the transitive property of parallel lines. Remember that the transitive property of equality said if A equals B and B equals C, then you can transition out that middleman and A is equal to C. So here's what the transitive property of parallel lines says. If two lines are parallel to the same line, then they're parallel to each other. This helps when you do this in colors a little bit. So let's just start with colors. If A is parallel to B, so if we know those two lines are parallel, so A is parallel to B, that is marked with these single triangles. Those are parallel. But it also says that B is parallel to C. Those are marked with those double triangles right here, so those are parallel. Then what do we know? Well, if pink is parallel to green, and green is also parallel to yellow, what does that mean about these outside pieces? Transition out that middle line. We're going to know that A, so I'm going to do that in color, A is going to be parallel to C. So two lines parallel to the same line are going to be parallel to each other. Then we have something called the perpendicular transversal theorem. We don't expect you to be able to memorize this, but we do want you to be able to map it out. So here's it in words. If a line is perpendicular, meaning it crosses it at 90, to one of two parallel lines, it's going to be perpendicular to the other line as well. So let's do that in colors, okay? If we know that M is parallel to N, and again, y'all, they have those triangles on there so you can kind of see it right here. These are parallel. So if those are parallel, M and N, and you know that T, this transversal, is perpendicular, meaning it's crossing at 90 to the pink line, so T is perpendicular to M. We also know that that line, T, that is a highlighter. Let's change it to a pen. Sorry, y'all. We know that T is going to be perpendicular, just means perpendicular, crossing at 90 to that green one, which is N. And we know this because we learned a theorem that said if the lines are parallel, 5 things were true. One of those 5 things said that corresponding angles are congruent. So if this corner is a right angle, this top right corner is going to be a right angle as well. So we got to add it there because of the corresponding angles theorem. So then it turns that yellow and that green into perpendicular as well. All right, next one. Next one sounds scary, but again, it's not. Lines perpendicular to a transversal theorem. In a plane, if two lines are perpendicular to the same line, they're parallel to each other. So if we have this line P sitting here, if P is perpendicular to N, meaning it crosses at 90, but we also know that P is perpendicular to M, so we do that in yellow, crosses at 90. What do we know about M and N? We know that M and N are going to have to be parallel to each other. So M is going to have to face the same way and never ever cross line N. How do we know that? We learned a theorem called the converse of corresponding angles theorem, which says, hey, if these are congruent, then boom, these lines must be parallel. So in my class, we said boom, parallel. So if those are both 90, then those angles are congruent. And if those angles are congruent, then the converse of the corresponding angle theorem said boom, parallel. So M must be parallel to N. So y'all, honestly, you're not memorizing this stuff. You're just going to draw it out and map it out and see what relationships must be true, and we'll do a little bit more of that in a second. So it says determine which lines, if any, must be parallel. Y'all, when it says if any, what that implies is there might not be any. So let's just look at what's marked. You can only go based off of the markings in the diagram, the tattoos that are present. Even though it looks like E is parallel to F and G is parallel to H, we have to go based on what's marked. So what is marked? We have a right angle at E, and we have a right angle on line E right here, and we have a right angle on line E right here, okay? And so there's these points. I'm going to do this one and this one. There's those points. Well, what is the transversal? What is in my class, we call that the bow and arrow. What is the transversal that is touching each of those? That transversal would be line E. What two lines does it go through? That hits through G and through H. And so what lines can we say are parallel? We would say that G is parallel to H, and it wants to, I don't think it has us give a reason, but if I wanted to give a reason, we would say the converse of what kind of angles are those? Those are alternate exterior, converse of alternate exterior angles theorem. those have to be parallel to each other. G and H have to be parallel because the alternate exterior angles are both right angles. And so those are congruent to each other. And so boom, parallel. G and H must be parallel. All right, again, look for the tattoos, y'all. So it looks like B, C, and D are parallel, just visually in this picture. But I only have the markings, the right angles here and here. I only have those perpendicular marks here and here. And so what transversal touches both of those? A is the bow and arrow. It touches both of those. So which lines must be parallel? That would be, let's get a highlighter. That would be line B and line C. Line D does not even contain a right angle, so we're ignoring that right now. And so we would say that B is parallel to C. B is parallel to C. It doesn't ask for a reason, but if you gave a reason, you could say the converse of alternate exterior angles theorem. Both of those are right angles, and so they must be congruent to each other. If the alternate exterior angles are congruent, then boom, these lines must be parallel. All right, let's look at this group. Now this group is interesting because I've got an angle right here in this group of 4, and then I've got a right angle right here in this group of 4, and the important part is to ask yourself, is there a bridge or a transversal connecting those two groups? So I've got a bridge between these two, I've got a bridge between these two groups, I've got a bridge between these two groups, but looking at this group, all 4 of these groups, those are diagonal to each other. So I've got a right angle here, and I've got a right angle here, but there's no transversal connecting each of them. And so what we're gonna put is we do not necessarily have enough information to say which of those are going to be parallel to each other. So as of now, we're gonna say not enough information. There's not enough information to say if any of those lines are parallel to each other, okay? We don't have a bridge connecting the two right there. Not enough information. We're not saying they're not parallel, we would just need more in order to make a conclusion. Now, it says for each combo of relationships, determine whether line P and line S are parallel or perpendicular. So every time we're looking for the connection between line P and line S. So let's look at this. Let's go ahead and map that out. So it says P is perpendicular to R. The first thing I'm gonna do, I always draw it flat because I'm a creature of habit and I have more room. Line P, it says, is perpendicular to who? It's perpendicular to R. So I'm going to draw R going straight up and down somewhere through line P. And I'm going to put a right angle right there. And then what does it say about line R? Line R is going to be perpendicular to line S. So I need to draw line S, and I need to make it crossing at a right angle. Okay, that is a right angle box. I could also do it this way. So that is line S. It wants to know, well, y'all, what is the relationship between line P, which is in pink, and then line S, which is in green? What is their relationship? That is going to be parallel. Those are facing the same way. So line P is going to be parallel to line S. All right. Now let's do that again. I'm going to start in pink. Line P, it says, is perpendicular to line R. So I'm going to draw it crossing at a right angle. Again, we don't have to memorize these. We're just mapping it out. And then what do I know about R? Well, it says R is parallel or facing the same way to S. So here is P, here is R. R needs to be facing the same way or parallel to S. So I'm going to draw S going straight up and down because R was going straight up and down. So it wants to know, well, then what is the relationship between pink and green? What are those going to be to each other? We have those theorems at the top that explain these. Those are going to be crossing each other at a right angle. So what we would say is that line P is going to have to be perpendicular to line S. Those cross each other at 90 degrees. That little upside down T symbol just means perpendicular. All right, and now we have the waterfall. P is going to be parallel. So I'm going to draw it this way. You can draw it whatever way you want. To R. So here's R. Those are parallel. Y'all really need to be putting triangles on these. These are parallel. Okay, but we also know that R is going to be, it says parallel to S. So I'm going to put an S here. I'm going to put 2 triangles to show that those are parallel. Okay, so 2 and 2, 1 and 1. So what is the relationship between line P and line S? Those are going to be parallel to each other. So really, I'm sorry, y'all, all along I should have been doing this. I mark the perpendicular with the 90. R is parallel to S, so I need to put a single triangle on this one, single triangle on this one. And then same thing here. Those are perpendicular, so I put the right angles. So y'all, you're just drawing a picture and you're seeing what is the relationship between the two that they give you after you draw the picture. Okay, so this is a 3-part. So let's start at the beginning. P is perpendicular to Q. So I'm going to switch colors. Q is going to go this way, anywhere you want it, but it has to cross at a right angle. Okay? So P is perpendicular to Q. Q is facing the same way. It's parallel to R. So I need to draw a line facing the same way as Q, and I'm going to mark those with a single triangle. Those are parallel to each other. And then we know that R is going to be perpendicular to S. So I'm going to find R, and I'm going to cross R at a right angle. I'm going to call that S. We want to know what is the final relationship between line P, which is facing this way, and then line S, which for us is facing this way. Those, of course, are going to be parallel. So line P is parallel to S. Okay? All right, again, these are the hardest ones, the ones that are multi-part. So line P is perpendicular to Q. So I'm going to draw those crossing at 90 degrees. I'm going to call that Q. And then Q is parallel to R, so Q and R face the same way. Again, I'm going to put a single triangle to show that those are parallel. And then we know that R is parallel to S. So I'm going to draw another line facing the same way. I'm going to do 2 triangles on that one in green. I'll do 2 triangles on that one in green as well. So those are parallel as well. There's line S. It wants to know ultimately what is the relationship between line P and then line S. Those are going to be perpendicular to each other. Those are going to cross each other at 90, and those are going to be perpendicular. So this is, it kind of looks like streets. I think one of the examples that y'all will see later is an example from Auburn, where we have Thatch and College and how they're intersecting. And so y'all will just sketch that out. All right, when it says proofs about lines cut by a transversal, there's not much to write here. This is just a little note. You cannot use alternate interior angles theorem, alternate exterior, corresponding same side interior or same side exterior theorem until after you know the lines are parallel. Okay? So if you are ultimately trying to prove the lines parallel, A is parallel to B, P is parallel to Q. This one, eventually we will get there, but in my class we say boom parallel. So if that's what you're trying to do, you have to use the converse. If the statement says blank is parallel to blank, you're going to use the converse, which we're going to abbreviate to CONV, in your proof. Okay? You thought we were done with proofs. We're not. I know y'all are so excited. I know you're smiling. I know you're just trying to contain your enthusiasm watching this video, okay? What are we given on this first proof? Y'all, I promise these are not bad, okay? Just like anything, it takes practice, and we can teach y'all some tricks to make them a little bit easier. So what are we given? We are given that angle 1 is congruent to angle 2. So find that in the proof, and y'all, these are free cash money points. What do you put for the reason? Boom, it was given. You can't solve a problem unless you're given a problem. So we are given that angle 1 is congruent to angle 2. Okay, what are we ultimately trying to prove? We are trying to prove that A is parallel to B. So immediately I know that that is going to be a converse of whatever it was that was used before it. Okay, so let's just go ahead and get started. How do I know that 2 and 3 are congruent? So here's 3. How do I know that 2 and 3 are congruent? Well, let's look at that relationship. What is the relationship between 2 and 3? Well, those are vertical angles. So by our vertical angles theorem, if those 2 angles are vertical, they must be congruent to each other. So now I want you to pay attention to something. We know that 1 is congruent to 2. We also know that 2 is congruent to 3. So cut out the middleman. Who's our transition piece? 2 is in each of these. So if 1 is congruent to 2 and 2 is congruent to 3, I can cut out the middleman and say, hey, get rid of the 2's. 1 is also going to be congruent to 3. What property is that? That is going to be our transitive property. So that is our transitive property. Is it of congruence or equality? Because these are congruent symbols, that is going to be our transitive property of congruence. So 1 is congruent to 2. 2 is congruent to 3. So we know that ultimately angle 1 is congruent to angle 3. That's by our transitive property of congruence. Well, why does that matter? Because if 1 and 3 are congruent, let's look at that. Here's 1. Here's 3. If 1 and 3 are congruent, what does that tell me about our lines? Our lines must be parallel because of what kind of relationship is that? That is the converse of corresponding angles theorem. If those angles are congruent, then boom, the lines must be parallel, which is what I wanted to prove. Because if the corresponding angles are congruent, then we know that those lines must be parallel. Okay? Not an easy thing, but you will get the hang of this the more you do. All right, I like to find my givens first. So there's S is parallel to T. Cash money points, those are givens. Okay? What else is given? I like to go ahead and find it so I don't lose it later. Measure of angle 1 plus the measure of angle 9 equals 180. We know that's going to pop up somewhere. That's my other given. So y'all, you already have, of this 6-point proof, you already have 2 points. And you know that if you are ultimately trying to prove that two lines are parallel, it must be the converse of whatever happens before it. So the converse of something, okay? So I've got some partial credit. So if we know that S is parallel to T, then why are angle 1 and angle 11 congruent? Well, what kind of angles are on 1 and 11 on those yellow lines? Again, those are going to be corresponding angles. That's the top left corner, they're on the same side of the transversal. One is interior, one is exterior. So that is going to be our corresponding angles theorem. I'm not using it to prove any lines parallel. I'm just saying, hey, we start by knowing that they're parallel. So because they're parallel, the corresponding angles theorem says, hey, those must be congruent. And if those are congruent, then their measures are equal. What allows you to say that? That is just the definition of that symbol, definition of congruence. You can also write out the word congruence. I'm not great at spelling, so I'm just going to stick to the symbol. Okay? Why do we want to get measure of angle 1 equals the measure of angle 11? Because now I'm able to use those and write an equation, which is given to us. Measure of angle 1 plus the measure of angle 9 is 180. That's given. And then look what they change. They leave everything else the same, but all of a sudden, they change the measure of angle 1. They switch it out to be the measure of angle 11. What allows y'all to do that? Step 3. The step 3 says angle 1 is equal to angle 11. So I can sub out or substitute out the measure of angle 1 turns into the measure of angle 11. So that's going to be substitution. You know, that's a lot of T's. That is our substitution property of equality. We're subbing it in. And so if 11 and 9, so here's 11, here's 9. If 11 and 9 add up to 180, what does that mean about these lines, P and Q? Here's P, here's Q. If 11 and 9 add up to 180, then that means that those lines must be parallel. Why? Because that's the converse of whatever kind of angles these are. Well, what kind of angles are these on those lines? P and Q. On P and Q, those are going to be same side, interior angles theorem. That's the converse of that theorem. If these add up to 180, then boom, these lines must be parallel. Again, not an easy thing. Y'all will get better at this the more we do it. All right, last one. Last one we've got, P is parallel to Q, is a given. Free cash money points. What else is given? S is parallel to T. S is parallel to T. Where is that at? That's right here. That is a given. I'm going to put that in this color. So we have P is parallel to Q. So I'm going to mark that with some triangles, single triangles. And then S is parallel to T. I'm going to mark that with double triangles. Okay, so those are parallel. Okay, let's make those a little bit prettier. That is not great. Okay, and so why, if the yellows, S and T, are parallel, why are 1 and 11 congruent? Well, what kind of angles are those on the yellow lines? Those are going to be corresponding angles. So that's our corresponding angles theorem. Okay, 1 and 11 are congruent. And then it tells us P is parallel to Q, and that 11 is congruent to 7. So let's go find those on the pink lines. Here's 11. That's also congruent to 7. Well, what are those on the pink lines? That's also the corresponding angles theorem. Okay? And so if, let's go ahead and follow this flow, if 1 is congruent to 11, and if 11 is congruent to 7, what property can we use? Well, we can use the transitive property to transition out that middleman. Follow your colors, Miss Hall. There we go. Transition out that 11. 1 is congruent to 11. 11 is congruent to 7. So 1 and 7 must be congruent. That is going to be our transitive property of congruence. And that is what I ultimately wanted to prove, that 1 is congruent to 7, which is where I arrived. So y'all, again, this part is the hardest part. Those are our proofs. There's only 3 of them. And then the front, you're just diagramming out and seeing, you're answering the questions on that front page. Our homework is on the back. We only gave you 3 proofs, okay? So you need to have something written in every single one, even if you're not positive if it's right. And then 1 through 8 is just working on that front section. So that is our 3.4 homework. And I want you to try those proofs. Progress makes perfection. We're not asking for perfection. We're just asking for progress. So we want y'all to try those, and we will check those tomorrow in class. I hope y'all are having a fabulous day. I miss you all. I love you all.